So we are looking at linear equations. We're going to look at what are they. So what do we mean by linear? We're going to look at BIDMAS and how it affects the order in which we do things. And finally, we're going to see how the rule works with these things. So we always have to do the same thing to both sides, and we're going to look at why we do that and what it means. So first of all, what are they? Well, the linear in linear equations, it basically refers to the highest power of x that is in our equation. So as an example, let's say we've got, say, 5x plus 4 equals 49. Well, in this case, we've got an x on its own, right? There's no x squared or x cubed. This is actually, we could think of this as x to the power of 1. Anything to the power of 1 is just itself. And so we could add a power of 1 there. It doesn't change anything, but it's just, it allows us to think of this as in terms of like powers, right? So we would say this x has a power of 1. And because it's got a power of 1, because there are no x squareds or x cubes or anything higher than that, we would say this is a linear equation. As an example, to the contrary to this, if we had, say, 3x squared plus 4x minus 7 equals 12. Well, in this case, because we've got an x squared here, we've got x to the power of 2. The fact that we've got a power of 2 in our equation means that this equation is no longer linear. Even though we've got x to the power of 1 in the equation, that's trumped by the fact that we've got an x squared or an x to the power of 2. And so we'd actually say this equation is quadratic. And you may have heard of the quadratic formula. That's why we call it the quadratic formula. It's because it applies to quadratic equations. The equation part, or equation just means anything with an equal sign, right? So it's anything where we have to solve for a particular value for x, there are only certain values of x that will satisfy that. Right, BIDMAS. BIDMAS, the easiest way to understand how BIDMAS relates to solving linear equations is probably by thinking of a fairly simple example of a number machine, right? So let's go back to this simple example, right? We've got 5x plus 4 equals 49. And we know from BIDMAS that we do multiplication first, and then we do addition afterwards, right? So we would do 5 times x, and then we take that whole result, and then we'd add it onto 4. Well, if we think of this in terms of a kind of number machine, right? We start off with x, we times x by 5, and then we take that result, and then we add 4 onto it, and that then gives us the final result of 49. Well, that's how we can represent this equation in a kind of number machine. The tricky thing is, though, we want to find out what x is, right? We want to go back down the opposite way. We want to kind of fight against the current almost. We want to undo everything we've just done. And so we're kind of starting off with 49. We want to go back down the other way, and we want to reverse this adding 4. What's the opposite of adding 4? We know we have to minus 4. And then we take that result, and we have to do the opposite of timesing by 5. What's the opposite of timesing by 5? It's going to be dividing by 5. And that then undoes that times by 5. And then once we do those two things, we should get back to where we started, right? We should get back to that value for x. And whatever value we have here is going to be our value for x. We've kind of inadvertently solved the equation. We'll look at this in a couple of examples in the next slide. So that's BIDMAS, and that's how it relates to linear equations. Finally, the rule. So the rule is we always do the same thing to both sides. And this becomes very obvious when we actually look at a very similar example, right? So we could do, say, 5x equals 10. Right, well, we know from our 5 times tables, right? 5 times what gives us 10? We know 5 times 2 gives us 10, right? We know x has to be 2. Well, if we were to do the proper mathsy way of solving this, well, I want to get x on its own, right? I want to end up with x equals something. And to do that, I need to therefore get rid of this 5. And just like with our number machine, I always do the opposite to do the reverse, right? I wanna get rid of this 5, and we can imagine we're actually doing 5 times x here. Well, the opposite of timesing by 5 is dividing by 5, right? So I divide that side by 5, and the whole reason I do that is to then cancel out that times by 5. So if I've cancelled that out, I might just put that in red actually. If I've cancelled out that times by 5, the only thing I'm left with is going to be x, right? I'm doing x times 5 divided by 5. And obviously if I make it 5 times bigger, then 5 times smaller, I get back to my original x. Well, if I don't do the same thing to the right hand side, I end up thinking that x equals 10, right? Which we know isn't true. We know the solution to this equation is x has to equal 2. So I have to do the same thing to both sides. I have to divide this side by 5 as well. And if I do that, I do 10 divided by 5, or 10 divided by 5 is going to give me 2. And again, we get our answer. So that's why we have that rule. We always do the same thing to both sides. Right, let's look at a couple of examples. So first of all, let's do question 8. So we want to solve 5 brackets x minus 6 equals 65. Well, another way to think about this is we want to work our way in towards x, right? Just like on the number machine, we work our way back towards x. Well, we do the same thing here, right? So we kind of start off outside, further away from x, and then we move in, and then we take care of the 6, and then we end up at x. Right, we're doing the opposite to BIDMAS, because with BIDMAS, we would take care of the minus 6 first, and then times that whole thing by 5. When we're doing the reverse, when we're working our way back towards x, we do the opposite of BIDMAS. We start outside the brackets, we do that first, and then we work inside the brackets at the very end. So the first thing we do is we take care of this 5. Well, you know, if I write this out slightly bigger, we're doing 5 times x minus 6 equals 65. And if I want to get rid of this 5 times here, well, what's the opposite of timesing by 5? The opposite of timesing by 5 is dividing by 5. And I do the same thing to both sides because of that rule that we just covered. And the whole reason I do that, right, is to cancel out that timesing by 5. So what I'm left with on the left-hand side is going to be x minus 6. On the right-hand side, I've got to do 65 divided by 5. Well, that's going to give me 13. And the final thing we need to do is we need to get rid of this minus 6, right? I want to end up, at the end of the day, I want to do a load of maths, and then I want to end up with x equals something, right? And that thing in that box is going to be my answer. So how do I get rid of that minus 6? Well, what's the opposite of minus 6? The opposite of minus 6 is plus 6. And so I plus 6 to both sides. And again, the reason I do that is to cancel out that minus 6. And so all I'm left with on the right-hand side, on the left-hand side, sorry, is going to be x. Well, we also have to do plus 6 to the right-hand side. We do 13 plus 6, and we get 19. And that is our answer, right? We've kind of inadvertently arrived at our answer just by following these very simple rules. We get x equals 19 as our answer. Right, final question, question 20. In this case, it's not quite as obvious, right? Which, you know, for the above question, we knew that this left-hand side was going to be the side that we wanted all the x's to be on, right? We said this is going to be our x side. We said we want to end up with x equals something. Well, in the case of question 20, it's not as obvious, right? We've got x's on both sides. And so do we want to get x equals something, or do we want to get something equals x? Both are going to be valid, but we want to decide now what we're going to be aiming for. And I think because we've got more x's on the right-hand side already, we've got 5 here and 3 here, we're going to say this is our x side. So if we want to get all the x's onto this side, well, at the moment I've got a few x's over on the left-hand side, so I want to get rid of this 3x floating around here. Well, to get rid of that 3x, at the moment, this 3x is adding on to 12, right? So what's the opposite of adding on 3x? I just subtract 3x. So I subtract 3x from both sides. And I know, therefore, that's going to cancel out with that 3x. And I'm going to end up with just 12 on the left-hand side and 2x on the right-hand side. And I've still got that plus 4 lingering there. I could also try and get rid of this plus 4, right? Because I want to get, at the end of the day, if this is my x side, I want to end up with doing a load of maths and eventually ending up with something equals x. And so I need to get rid of this plus 4. How do I get rid of that? Well, what's the opposite of plus 4? It's going to be minus 4. So I'm minus 4 from both sides. 12 minus 4 is going to give me 8. And again, the reason we do that is to cancel out that plus 4. So we're left with 8 equals 2x. The final thing I need to do is get rid of this 2. Well, what's the 2 doing to x? The 2 is timesing the x. Right, we can imagine there's a very small times sign in between the 2 and the x. The opposite of timesing by 2 is going to be dividing by 2. And so I can divide both sides by 2. And that's going to give me 4 on the left-hand side. Again, the reason we do that is to cancel out that timesing by 2 on the right-hand side. And so we're left with 4 equals x. And that is my answer. And that is the end of linear equations.